Hello, grade 12s. We are doing mechanics, which includes Newton's laws, vertical projectile motion, momentum, and impulse. And in total, it's out of 65, about 65 marks in paper 1. The focus will be the momentum and impulse. We'll have about 7 videos. That is introduction, change in momentum, Newton's second law in terms of momentum, impulse, conservation of momentum, elastic and inelastic collision. Don't forget to subscribe, like and share the videos. Let's define the momentum. Momentum is defined as the product of the mass and the velocity of an object. So you remember that the mass is in kgs. You must make sure that the mass is in kgs. Then the velocity must always be in meters per second. And remember that the mass is a scalar quantity. The velocity is the vector quantity. The symbol for the momentum is P, small letter P. Momentum has a symbol small letter P. By the definition, it is the product, which means we multiply the mass and the velocity. So P is equal to mv. That is the formula to calculate the momentum. And make sure that the mass is in kgs, the velocity is in meters per second. And another thing that we need to make sure is that when we calculate the momentum must have the magnitude and a direction. So the momentum is a vector. It will always take the direction of the velocity. If the velocity is directed, for example, to the right, therefore the momentum will be directed to the right. The SI units of the momentum is, since the mass is in kgs, then the velocity is in meters per second. Therefore, the SI units for the momentum will always be kg meters per second, right? So if it happens that your mass is in grams, let's say you have 10 grams, the mass is 10 grams, you have to convert the 10 grams to kilograms, which means we are going to divide by 1000 to get the mass in kilograms. That is 0.01 kg. Always check the SI units. If the speed is not in meters per second, for example, let's say you have 50 kilometers per hour. 50 kilometers per hour. So you need to divide by 3.6 so that the speed will be in meters per second. So it's 50 divided by 3.6. Then we have 13.89 89 meters per second. Let's say it was directed to the right. So the question says calculate the momentum. So remember, the formula for the momentum is mv by the definition, product of mass and velocity. So we can calculate the momentum now. So P is equal to, small letter P is equal to mv. So the mass is 0.01 times the velocity is 13.89 0.89. Then we get the momentum. The answer is 0.139. Then since we are talking about the momentum, that will be kg meters per second. Since the speed was directed to the right, we'll say right even here. So there is a mark here for the magnitude and the direction. Usual 2 marks here. That is the magnitude and the direction. Okay. Now let's look at, before that, the momentum depends on mass and velocity, because the definition says is a product of mass and a velocity. An object that has a greater mass will have a greater momentum, meaning that if you have a bigger object compared to a smaller object, the bigger one will have a greater momentum. What does that mean? If they are running, for example, or is moving, the bigger one will not stop quickly. Kuzoba nzima bayistophe because it has a greater mass. It has a greater momentum, right? That is the first factor. If mass is high or greater, therefore the momentum is greater. Then another factor that affects the momentum of an object is the speed. The object that is moving fast, it is not easy to stop it because it has a greater momentum, meaning that if the speed is increasing, so does the momentum, meaning that the momentum will increase also, right? Let's go to the example. Example 1. An athlete with a mass of 70 kgs. So the mass of an athlete is 70 kgs, runs at a velocity of 45 kilometers per hour. Now remember that we said the speed must always be in meters per second. The mass must be in kgs, not grams. So the mass is in kgs, which is correct, but the speed is in kilometers per hour, which means we have to convert this speed. How to convert the speed from kilometers per hour to meters per second? We are going to divide by 3,6. 3,6. Then we get the speed. So we have 45 divided by 3,6. The answer is 12,5 meters per second. Let's just say to the right. Right? So we have the mass, which is correct. So the mass is 70 kgs. Then the question says determine the athlete's momentum. The momentum is represented by P. So small letter P is the momentum, which is equal to mv. The mass is 70 times the mass is 7 times the speed is 12,5. 12,5. So the answer is it's 70 times 12,5. It's 875. So we have 875 kg meters per second. Since the direction of the velocity is to the right, which means this one will also be directed to the right. Then we're done with this one. Now let's go to another example. Example number 2. Which one of the following moving objects will the most difficult to stop? Okay, we have object 1 which with 100 kgs and is running at 12 meters per second. Then we have object 2 with 80 kgs and is moving at 15 meters per second. So which one is moving, or which one of the following objects will the most difficult to stop? Remember I said the one with the greater momentum will not stop quickly, which means it's not easy to stop it. So let's calculate. Let's start with object 1. In object 1 we have the mass, which is 100 kg. So mass is equal to 100 kgs, right? Then is moving at 12 meters per second. That is, the velocity is 12 meters per second. Let's just say east, right? Then we want to calculate the momentum. So momentum is mv. So the mass is correct, kgs. The velocity is 12 meters per second. That is correct. Therefore we can substitute. So we have the mass, which is 100, times the velocity, which is 12. Then we get the momentum, which is 1200 kgs meters per second. Since it is towards east, which means the momentum is also directed eastwards. So the direction is eastward, right? Then let's go to object 2. The mass for object 2 is 80 kgs, which is correct. Then the velocity is equal to 15 meters per second, correct, because we don't want grams, we don't want kilometers per hour. So the momentum will be equal to mv. So the mass is 8, the velocity is 15. Then we press the calculator. So we have 8 times 15. Then the answer is 1200, which means they have the same momentum. They have the same momentum, which means there is no one that will be difficult to stop between the two, right? That's how it is. That is the momentum. Okay. Don't forget to subscribe, to like, to share, to comment. Please, let's go to the next video, which is the change in momentum. That is the change in momentum. This is the video that we are going to, the change in momentum. Thank you.